All right, we got the simplification stuff. None of these, there's only a handful of these that are actually too hard. They're not too bad. We're just going to distribute that -4 to everything. We're going to have 2 to the -4th. -2 times -4 is 8. Now we're going to shift that 2 to the 4th down low because we know that x to the -n is 1 over x to the n. And lastly, we're going to evaluate 2 to the 4th. We're going to think 2 times 2 times 2 times 2, and hopefully we're going to get 16. So that's easy. Before we have multiplication, we should know that when we multiply like terms, we add the exponential space. This becomes x plus 2x is 3x minus 3. Now, if you want to be all fancy like, you take this a step farther. There's a couple things you could actually do. You could do that, couldn't you? Anyways, where was I? You should be familiar with this property. And I break apart division through subtraction. So if I read it from right to left, I can think of this as e to the 3x over e cubed. This one actually really reduces on down. I did not realize this one reduced that far down. This is going to reduce down to something really funky. I noticed that both of these have a 3. I can write this as e to the x over e all cubed. Or, which doesn't do me much good, I can think of this as e cubed times, no, I can't. Never mind. I'm probably too tired today to be doing math. That's where it stops. Trying to make a mountain out of a molehill. All right, number 7. 7 is a cubic root. Cubic root of 8 is 2. So there's a 2. Wow, thank you. The deal with these is you divide. Would you close the door for me? Power by the root. And the remainder stays inside, if there is one. So I'm looking at this 9x, and there's that 3. I take 9x, I divide it by 3, and I get 3x, 0 remainder. So all that's outside is e to the 3x. The x is probably bothering you, but don't be. Just follow the rules on exponents. She didn't close the door, so we close the door. That was Kaylee Jarrett who was supposed to close the door for me. Way to listen, Kaylee. All right, number 8. I didn't do one of these in class with second period, but I did the rest of the day. 6 over 8. Everybody knows is 3 over 4. Think about this property where we subtract exponents. There's more up top. So e to the 4x minus a 2 minus 2x minus a 1. 3e, 4x minus 2x is 2x. -2 minus -1 is -1. Still sitting pretty over 4. And there was a property I used on a previous page here. Have this -1. I can put a 4e to the understood 1 down low because there's 2x minus 1. Try and establish the connection between that. Hopefully you see it. I know how kids feel about exponents. Kids literally just murder the properties of exponents, and that's the problem. We give you a property and you either don't want to memorize it or you're just like, well, this doesn't make sense. I'm not going to believe this, but that's how they work. 9, we got a pretty old square root there. This one's going to be fugly, maybe. I don't know. I notice there's a 4 times a 27 inside, and there's a 3 down low. And I think about 27 and 3. 27 divided by 3 is 9, and that makes 36. So that number cleaned up to be 36, which is something I can take the square root of. I'm going to start looking at my e's. I have an e to the 13th and e to the 7th. I subtract exponents. 13 minus 7, I'm pretty sure, is a 6. And then I'm looking at my x's. I have an x over an x to the negative 3rd. I'm going to move that up top. X times x cubed, and I'm going to get x to the 4th. And every bit of that is evaluatable. The square root of 36 is 6. And by the way, the square root has an understood 2. 2 goes into 6 3 times, e cubed. 2 goes into 4 2 times, x squared. All right, that's that. I think there's some function stuff to work with, some F and G notation. Oh, no, there's this guy, evaluate with a calculator. I didn't do this in class. I ain't gonna do this in class. I guess I should, you know, just to give some kids a confidence booster. But 12 says, find 5e, when I hit the wrong button, second natural log to the negative 2/3. 2.5671. It says fourth decimal. 2.5671. The only reason this is even on this piece of paper is to make you realize where the frickin' E key is. That's it. No other reason. All right, 2 left to go, and then I get to enjoy my lunch break because I'm working through my lunch for you. 14 is find fog and state the domain, and this is f of g of x, which means that I'm going to take all this pretty stuff right here and I'm going to put it right there. Notice how I just replaced that x with that. And then I'm going to do some work on the interior. 3 times 2 is 6. 3 times a negative 8 is negative 24. Then I have to take away 4 more, so minus 28. The domain's the kicker, man. And I wish these numbers were prettier, but they're not. They're not pretty at all. Oh, it stinks. But the domain on this one's pretty bad. So I'm going to do this down here. The deal is, for the square root of anything, whether it be a smiley face or something, the smiley face has to be greater than or equal to 0. So I have to take 6x squared minus 28. It is greater than or equal to 0. I add 28 to both sides. I divide by 6. 28 over 6 is reduced to 14 over 3. I take the square root, and these are kind of funny how these work. It's this is actually the equation of a circle, or half a circle. It's the equation of a semicircle. Let me show you that. Square root. Okay, I'll use my keypad over here since that little touch screen's not working. By the way, looking at graphs is a great way to think about domain. Should see a semicircle show up if... Oh, nope, I got this one right. This is half of a hyperbola. Shows how tired I am. It's a square inside, isn't it? Go zoom 9. Sorry, zoom square. Be better drawing of hyperbola. You'll notice it's valid, it's drawn when I'm less than something on this side and greater than something on this side. So I'm going to use that knowledge when I come up with my two answers. X is going to be greater than or equal to the square root of 14 over 3. That's one big square root. Or X is less than or equal to the negative square root of 14/3. Because when you take a square root, you know you introduce the whole plus or minus symbol. So your domain for this thing, as fugly as it is all values of X such that X is less than or equal to the negative square root of 14 over 3, and that's all in a radical. And X is greater than or equal to the positive square root of 14/3. And there's the work justifying my answer. I know you don't have enough room there for that. Sorry. 17 says find G over F, state the domain. G, and everybody, every student I have can at least write G over F. I don't know, I don't understand how that is hard. I don't get it. The domain you're going to struggle with. All right? There are two rules. One of them's over here. All right? The other one is you can't divide by 0. Because of where this thing is, these two rules get combined. Because I have a square root down there, I kind of have a third rule, which is a creation of the opposite. So when I take those two rules and I put them together, or 1 over the square root of something, we'll make a smile at frowny face because that's how you feel. The frowny face can't be 0. It has to be bigger than 0. So when I talk about my domain, 3x minus 4 is bigger than 0. I slide and divide, and I get that x is greater than 4/3. So domain, all values of x such that x is bigger than 4/3. Finish the curly braces. Pretty sure that's it for the homework video. Thank the Lord, because I am exhausted and I don't want to do this anymore. Have a good day.